So today we will do the problems related to the chapter electricity. Topic it's from heating effects of electric current and electric power. So we will do the first problem. The question is Phy10, an electric iron of resistance 20 ohm takes a current of 5 ampere calculate the heat developed in 30 seconds. That's a question. An electric iron of resistance 20 ohm takes a current of 5 ampere. Calculate the heat developed in 30 seconds. So, when you do the problems related to this heat energy or heat developed or heating effects of electric current, the first important thing is that the time should be in seconds. If it is given in hours or minutes, you have to convert it into seconds. Okay. Then we will write what all things are given in the question. According to that, we will just select which equation we need to use to solve this problem. So, first one R is given, the resistance is given, R is equal to 20 ohm. Then current is given, I is equal to 5 ampere. Then time is given, that is 30 seconds. Here the time is given in seconds, so no need to worry about it. If it is given in hours or minutes, you have to convert it into seconds. Now, I is given, R is given and T is given. We know three equations are there to find the heat developed, that is H is equal to I squared RT, that is equal to VIT, that is equal to V square T by R. So, any of these three equations you can use and find the heat developed. So, we will select the simple one, direct substitution. We will select, we will select the equation H is equal to I squared RT. Direct way you can substitute in the equation and you can find the answer. So, we will write the equation like this, H is equal to I squared RT, that is equal to five ampere square into 20 ohm into 30 seconds. So, when you do the substitution, you will get the answer in joule. Okay, it's clear. So, we will move to the next question, that is second question. Compute the heat generated while transferring coulomb of charge in 1 hour through a potential difference of 50 volt, through a potential difference of 50 volt. So here calculate the heat energy while transferring this much coulomb of charge in 1 hour through a potential difference of 50 volt. From here you can find current. I is equal to Q by T. Then you can find the heat developed. So simple method I will use here, that is charge Q is equal to 96000 coulomb, then potential difference equal to 50 volt. Now we know that the equation work done will be converted to heat energy. So you are calculating the heat energy means you can calculate the work done, that will be equal to the amount of heat energy. So work done is equal to heat energy, that is equal to Q into V. Q into V. So you will get an equation like this. Now you can substitute in this equation. So Q how much? 96000 coulomb into potential difference is 50 volt. So when you do the calculation, you will get the answer. Okay. So instead of calculating this I from this I equal to Q by T and using the equation H is equal to I squared RT OVIT OV square T by R, direct way you can use this equation. Work done is equal to heat energy, that is equal to Q into V. So direct way you can substitute and you can find the answer. Okay. So next problem, question number 3. An electric bulb is connected to a 220 volt generator. The current is 0.5 ampere. What is the power of the bulb? What is the power of the bulb? So we need to calculate the power of the bulb. The question is, an electric bulb is connected to a 220 volt generator. The current is 0.5 ampere. What is the power of the bulb? So first we will write what all things are given in the equation and what is to be find or calculated. Then according to that, what all things are given in the question, we will select the suitable equation and we will substitute in that equation and we will find the answer. So in this question, potential difference is given as 220 volt, then current is given as 0.5 ampere. We need to calculate the power. So three equation is there to calculate the power, that is P equal to VI, that is equal to I squared R, that is equal to V square by R. Any of the three equation we can use and find the power. So here to calculate the power, Vi we can select because V and I is already given in the question. So direct way you can substitute in the equation and find the answer. So P equal to Vi, that is equal to 220 volt into 0.5 ampere. 220 volt into 0.5 ampere. So when you do the calculation, you will get the answer, and the unit of power is watt, W-A-T-T. Okay, the unit of power is watt, so you will get an answer in watt. Okay, next problem. Fourth one, an electric motor takes 5 ampere from 220 volt line. Determine the power of the motor and the energy consumed in hours, and energy consumed in 2 hours. So an electric motor takes 5 ampere current from a 220 volt supply line. Determine the power of the motor and the energy consumed in 2 hours. So first we will write what all things are given in the question. So current is given 5 ampere, then potential difference is given 220 volt, time is given 2 hours. Now we need to find the power and also the energy. We need to find the power and the energy. So we can use the equation power V into I. Vi, that is equal to 220 volt into 5 ampere. When you do this, you will get the answer in watt. Now, we need to find the energy. Okay, we need to find the energy, that is energy equal to power into time. Energy is equal to power into time. So first important thing in calculating energy, the time should be in hours. If it is given in minutes or seconds, we need to convert it into hour. Okay, so here already the time is given as 2 hours. So when you calculate this one, you will get the power. So power you will get in watt into 2 hour. So you will get an answer in watt hour. You will get the answer in watt hour. If you want to convert it into kilowatt hour, you can divide it by 1000. So the answer will be in kilowatt hour. So power, you know, P equal to V into I. Energy, power into time. Here time should be in hour. If it is given in minutes or seconds, you have to convert it into hour. Okay, the answer will be in kilowatt hour or watt hour.